And good morning, welcome along to Design Theory with me, Miles. So I'm going to be talking this morning about architectonics. Architectonics. What the hell is architectonics? I hear you ask. Well, isn't it just as well you're attending this Design Theory online video tutorial? Because we're going to find out right now with a definition to begin with. Architectonics, let's just find out first of all, how do we even say that? Am I saying it right? Let's see. Let's listen a second, go for it, Google.
Architectonic.
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 Architectonic. Okay, well, I guess you don't have to say architectonic every time you say it, but architectonic. I think I'm kind of in the right ballpark. So yeah, architectonic is a noun referring to the scientific study of architecture. It's also to do with music, musical, literary, or artistic structure. We talk about the architectonics of Latin prose, for example. However, this is not a literary course, as I'm sure you're well aware. This is to do with design and architecture. So we'll concentrate on that first definition there, the scientific study of architecture, which leads us to another question, really. What's architecture? You think you know? Well, you probably do. I mean, yeah, you know, we all kind of think we know what architecture is, but good to be sure, right? Good to be sure that also the definition of architectonic is another slide here, relating to the principles of architecture, having an organized and unified structure that suggests an architectural design. So let's find out, what is architecture? What's architectural? It's Google, tell us again, how do we actually say this, please? Go for it.
Architecture.
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 Architecture. Okay, architecture. I think I was pretty close with that as well. So, again, architecture is a noun referring to the art or practice of designing and constructing buildings. Yes, I'm pretty much sure everybody was kind of thinking something along those lines. The synonyms, that is to say words that mean kind of the same thing when we're talking about architecture, are, you know, building design, building style, planning, building construction, formal, the architectonics of modern architecture. There's a second definition, the complex or carefully designed structure of something. For example, the chemical architecture of the human brain. And you'll often hear architecture of computing, for example, the architecture of the electronic circuitry within, for example, your laptop, or the laptop I'm recording this on now. So, okay, so we're clear on what's architecture and what's architectural, therefore. But to go back to architectonics, which is a kind of a hybrid word, actually. It's a hybrid between architecture and tectonics. So we know what architecture means. What about tectonics then? Well, the root of tectonics, and I'm going in the wrong direction with my slides there, the tectonics comes from the Greek word tekton, which means carpenter or maker. Okay, kind of interesting that it comes from the Greeks, because the Greeks are actually kind of by and large considered as being the birthplace of architecture, the birthplace certainly of what we call classical architecture. This drawing here on the right is a drawing of the temple complex city known as the Acropolis, where the ancient Greeks used to hang out, and it's still there. Well, it's kind of still there. It's kind of, you know, a bit of a ruin, I guess you would say, but still fairly well preserved and intact. So you can go and check out the Parthenon, the Acropolis, for yourself if you visit the city of Athens, and I definitely suggest it's well worth a visit. But anyway, I digress. We're going back to the definition of architectonics, the derivation of, as I say, the word comes from the Greeks, the Greek word meaning carpenter or maker, and the buildings are composed, I should say, of a complex arrangement of many different parts. I think we can kind of just stop and think about that one for a moment. Probably something that we just kind of take for granted. Buildings are arrangements of parts, things like the roof, things like the walls, the columns, the floor, the ceiling, the enclosure, the glass, whatever it is. Obviously, all of those things come together to create a building. Again, this is the Parthenon that you can see in that drawing previously. This is an elevation and a plan of the same. And we can begin to sort of look at this and say, we can see quite clearly defined parts to this building. Obviously, we have a roof element, which is supported in this example by columns. Yes? Arrangement of columns, regularly spaced columns which support the mass element of the roof up here, and they in turn actually rest on a base, a plinth if you like. In plan we can see that represented here, the circular elements around the perimeter, which are the columns holding things up. Inside, beyond those columns, we have the interior of the building, which is actually, again, a series of sort of spaces which are subdivided by walls, and there are openings between the various spaces. This is the various parts of the temple enclosure, okay, which form the plan and the spatial arrangement. Okay, so all of those elements come together to create the structure and the building, and they work together to form intermediately those tectonic elements, and they in turn work together to create the building, as I say, and the spaces within. You can see there's the example as it still looks today. As I say, it's a bit of a ruin now, but you can see quite clearly that this building is defined very, very clearly by those elements. The roof mass on top, and then the columns supporting everything, and then the stone base. Over here we have a very different example, obviously, contemporary, but the same kind of thing is going on. We've got a roof structure, which is also kind of a frame structure. It's held up by columns, which are supported on a base. It's the same kind of principles, in effect, although radically different, and obviously we've got curvature and stuff thrown into the mix. Here we've got something else. This is obviously just a computer diagram drawing of a design, but again, elements arranged to create a whole and a structure, and the appearance and the way that those things are coming together, the visible part of this thing and the way it's made. These are all the things that we're talking about when we're talking about architectonics. It's the structure and the experience of the building, that relating to the materials in particular, in this case stone columns, in this case steel space frame tubing, and whatever these probably concrete elements are. This we don't know because it's just drawing, but hey. Now, when we talk about architectonics, to simplify things a bit, we try and break things down into elements. In the diagramming and designing of architectural objects, there are actually 3 tectonic elements. And, well, I'm going in the wrong direction again, so sorry. So the first of those elements we would say is mass, all right? We talk about the mass of the building, all right? The mass elements. You can see in this example down here, you know, this is a fairly massive kind of building, but the mass elements of it are, you know, those elements that are kind of visible very, very clearly define the bulk of this building, the form of it, which is kind of, you know, a big box with bits and elements, corners, chunks, parts, whatever you want to call them, taken out. But that's the mass of the building, the mass, the overall form. You know, if we were looking at this from some distance away, what we would see, we would say, is the mass of the building. Then there are things like planes, okay, which by and large tend to be somewhat thinner than the massive elements of the building. You can see in this example here, you know, we have the planar element that sits on top here, there's the roofs, and then we have another one that defines the level below, and then one down here, and those are horizontal planes. Here we have vertical planes, which are defining and intersecting actually with the horizontals, but they're again defining this building architectonically. Starting to like this word yet? I'm going in the wrong direction again. Final one is frames. We have frame elements. Frames are very often going to define also the structure of a building, but can also define spatial elements. You can see here this pavilion design, I should say, is defined very, very architectonically by these frame elements, which are also creating, you know, a kind of portico almost as an entrance to the building. Okay, back to mass for a moment. So mass, as I was saying, is the bulk, or the size, the form, the silhouette, if you like, of the building. You can see that quite clearly here in these pretty massive buildings. Don't get confused between those two terms though. Massive and mass, they're two different things. A building doesn't have to be massive in order to have mass. Every building has mass, no matter its size. A garden shed has a mass, as does, you know, a large building like this. What defines the mass are the, you know, in this case, these very, very rectilinear box-like elements with some box bits kind of taken out of the middle here. You can see that. You know, it's almost like a piece has been deliberately removed, and that creates a very, very unique mass form for the building. Same here. This building is actually several masses coming together to form the overall mass, but you can see them, they're quite clearly defined. We have, you know, again, box-like forms coming together. They're even different colours to make things even more defined, let's say. And yeah, you know, so we've got one over here, then we've got another one here, and another one here. So just looking at this, you know, there are probably, let's count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, at least 10 different masses, I would say, creating the overall mass of this particular building. All right. Unlike this one, this blobby kind of form, which is kind of homogeneous, that means all one. Form, it's like a continuous form. It's, as I say, kind of blobby looking building, and if we were describing its mass, I think a blob is a nice word, or globule or something like that, you know. But again, you know, a very, very defined mass, obviously very, very different from this one. And again, with little pieces kind of removed and pieces sliced off even. You can see here where we have this, looks like a glazed element. Obviously this is computer rendering. Alright, next, planes. So as I said, planes tend to be rather thinner elements, and they represent enclosure, generally read as thin elements. So we have, for example, this pavilion here, two very, very defined planes, the roof and the floor, or the base element, whichever you prefer. So easy to read though, very, very defined thin line elements, supported or joined by a frame. These columns, these actually very, very thin structural elements. Over here we have something, this is a Frank Lloyd Wright building, very, very famous building called Falling Water. It's a house designed, as I say, by Frank Lloyd Wright for his, I believe, doctor client. Again, almost, wow, how old is that Falling Water now? It must be at least getting on for around about 80 years old, something like that now. Anyway, the mass of this building, as you can see, is kind of here in the center. It's defined by this stone elements, and then we have these intersecting elements, which are all massive in their own right, but they're also very, very planar because they are thin in comparison with this bulk in the center, and they cantilever out, so they're very, very clearly defined and easy to read as separate elements. Frank Lloyd Wright did this because he was trying to the site's beautiful site, a waterfall, river in the middle of woodland, as you can see, and he wanted to create this form that was somehow a part of nature, and yet very, very expressively defining, creating an architecture in its own right, but that was somehow integrated and growing out of the rock, was the way he put it. Anyway, we have an example here on the top corner of a model where we have, again, planes that are horizontal and vertical and intersecting in this example, so coming together to create a very, very particular architectonic structure and form. So, planes. Next, frames. So frames are the skeleton of the building. They're often stick-like, as we saw in this example, and they read as structural elements. That is to say, they are supporting stuff. All right. So it's functioning as structure very often. This is the Acropolis. This is a more contemporary example to show you that when we talk about frames, they don't necessarily have to be completely rectilinear or completely vertical. We can have curvature, we can have organic, if you like, but what we have still is the skeleton of the building, very, very clearly defined, the stuff that's holding the envelope of the building, and the rest of it is the frame, functioning as structure. This example here, again, a contemporary example of a sort of, I would call it biomorphic example of a biomorphic design for a skyscraper, where we have, a very, very organic overall mass to the finished design. And the way it comes together is this: we have a structure, okay, we have columns in the center of the building, at the core, okay, and from that we have slabs which are almost like petals in a way. It's very much like a tree, all right, with these slabs arranged up vertically along the axis of these supporting structure, okay, and then from that we have these glass elements which are beautifully organic and flowing and curving and all that kind of thing. And they define the overall shell, the overall enclosure, if you like. And again, there are cutaways to create a very, very interesting finished aesthetic. From my perspective, I really like this finished design, the completed design. But it's these three tectonic elements that are coming together to create the architectonics that are particular to this design. A simpler example, perhaps, in a diagram form, again, is this one where we have planar elements that you can see in the form of the roof, which, by the way, we have this kink at the end. Planar doesn't have to be horizontal, perfectly horizontal or vertical. We can have kinks and things like that. It's still a plane. And we have frames and columns, and we have walls that are defining the spatial arrangement within the building core, just the same as we had in that example I showed you at the very beginning of the Acropolis, where you have columns supporting everything above, and then within you have, the spaces, the different spaces, the cellular kind of arrangement of this particular building. Again, this is the architectonics, all of that stuff coming together to create the architectonics of the building. Doesn't have to be rectilinear, square. We can have twists and turns on things, as you can see in this example. So the frame can twist and turn, the planes can intersect with the frame, and so we end up with a very dynamic, I would suggest, design in this particular example. But those elements are still there: mass, frame, planar elements coming together to create an architectonic for this particular design. Now, where those elements are actually coming together and joining is to do with the material choices and the appearance, the technology used, and the overall structure, which are all design decisions. These are examples, here in the bottom corner we have an example of tubular steel pieces joined together at a junction plate using bolts, using what do we call this, a flange plate, for everything to join together at one point. This again is an exploded diagram, so we have other steel members coming in here to another flange plate. But this is all the detailed design. It's coming together in a very, very expressive way. As you can see over here in this example, this is from a close-up of the London Eye, the big wheel, if you like, in London, which I'm sure you know it. If you go and check out any pictures of London, you will, I'm sure, come across some pictures of the London Eye. It's almost an iconic part of the architectonics of London now, I would say, the skyline, that's to say. And if you get the opportunity, go on it. Go on the London Eye and see London from upon high. It's well worth it. But anyway, I digress. I'm talking about the stuff here, the framework, the steel work, the tubular steel members that all join together at this particular junction here. So this is kind of the main frame of the framework of the structure of the London Eye, which you can see is pretty massive. I would say probably we're talking 200 maybe millimeters cross section diameter, maybe even larger. I couldn't say for sure. And then we have even cable, tensile steel cable coming in here from this side. Okay, so it creates a very, very visible example, a visible example of a joint that's being expressed. That is to say, visible and celebrated. There's a a way of, creating an aesthetic for this design rather than stuff being hidden away or made to be invisible. It's the exact opposite. This is very, very distinct and visible design. A very, very engineered solution that, was the architect's intent. What to say about this one down here? Not too much, except that again you can see very clearly different elements of the structure coming together to create the finished form and enclosure and spaces and joints that create the building aesthetic and different materials and the way that they're joined together. Now, we can also talk about, as I was talking a minute ago, about architectonics at the other end of the scale. That's to say, the scale of the city. Architectural ideas and activities that take into account the appearance of buildings at the scale of the city. So here we have the example of New York, which I'm sure everybody knows. The Big Apple, the iconic city of skyscrapers. And I would say, the architectonics of New York are very, very much defined by this building form, the skyscraper, obviously. This is the Empire State Building. Now, the Empire State Building, a beautiful building, probably nearly, I guess, could even be, 80 years old, maybe even more. Anyway, but, it's a skyscraper, obviously. But look at its form. It has a sort of widening towards the base, almost a, long, thin pyramid. That's to say it tapers towards the top. This floors between, floor 30 and floor, 70 or something like that, is all kind of the same. But then the floors above, we got a slight tapering, right? We've got from floor 70 to floor 100 or whatever it is, slightly smaller in terms of its footprint on plan. And so basically that continues. And then when we get to the very top, we have there's the viewing gallery and all that kind of stuff. But then on top here, this pinnacle is actually not really usable space. It to be a little bit of architectural history. The reason for doing this was a lot of competition between building the next tallest skyscraper. And so a way of making your building taller was to put a big mast on it, big radio tower essentially, which, again, strictly speaking, it's not building at this point, it's a radio mast, as I say, but nevertheless reads as part of the building, and suddenly, hey presto, you've got the tallest building by 50 feet or so, because your radio mast is actually higher than the next one. So anyway, but my point is this: we can see this form repeated. If you look around New York, you're going to see this a lot. Okay, it's not just a box; it's a tapered kind of form. You can see it here. You can see it in this one. Where else can we see it? We can see it in this one. Just all over the place, really. Yes, there are lots of rectilinear skyscraper forms like this one here, which are essentially much simpler in form. This is a box and broken down into lots and lots of smaller boxes. This reads very, very much as a sequence of rectangles on the elevation here. And then, over here on the right, we have a relatively new edition, which is now taking this idea and not just tapering it, but also kind of faceting it, cutting bits away to create, again, a new aesthetic. What's interesting about this as well is you can still see, there's a strong relationship, this rectilinear stuff going on, but the form, the envelope of this building is essentially very lightweight. Is glass and is really reflecting the sky and the buildings around it. It's the same here on this one in the background. This is the One World Trade Center, the replacement for the Twin Towers. And this is, again, a faceted design. That's to say, different angular elements as on different elevations. And so it picks up the light, reflects the light differently. Still got the tapering though, still got the mast on top though. So that's what I mean about the architectonics at the scale of the city. And I think, in a city like New York, that's very, 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 recognizable. But we can also talk about it on the detail scale. And this is actually a detail of that building I was just talking about, the One World Trade Center. Where, I was just talking about, this is the glass element that actually is what we sort of see from afar. And you can see just how much of this building is actually just glazed skin. But that skin has to somehow stay on the building. It has to be joined to it, right? And the building itself cannot be made entirely from glass. There are big structural elements supporting this building, okay? And they are in the form of steel beams. And then those steel beams are supporting floor slabs. And those floor slabs then have to have detailed joints where they join the glass enclosure, the glass skin, as I say, of the building. And then the skin itself, there are joints between the different panels of glass, which again gives that building a unique kind of aesthetic and expression. Alrighty then, so little review. It's just a quick question for you, a quick review. Which of the following are examples of tectonic elements? One second while I have a swig of my drink. Well, answer A, mass. Answer B, frame. Answer C, plane. Answer D, all of the above. What do you reckon? A, B, C, D? Well, I'm going to hope you went for D. It's all of the above. Yes, remember, mass, frame and plane. They're all tectonic elements. What about structures? Structures can sometimes take on the form of two or more tectonic, I'm sorry, I'm having problems now. Tectonic elements. Is this true or false? It's true. Of course, structures can sometimes take on the form of two or more tectonic elements. That is to say, structure can have mass, and structure can be a frame, as I was talking about. Okay, tectonic elements exist in every structure. True or false? Again, what am I going to say? I'm going to say that's true. Pretty much every man-made structure, every man-made building has at least one of those elements. What about the word tecton? To go back to the beginning, the root word tecton means architect, carpenter, engineer, teacher. Hey, you know what? All of those things, right? But it actually means carpenter, remember. Okay. Good. To your mission for this week, should you choose to accept it. Assignment 1. Research tectonics. Okay, using the internet or library, I would like you to research and find an example of a building in which you can clearly see examples of mass, plane and frame. So you're going to have to make sure that you pick a building with sufficient photographic documentation for you to get a sense of how the tectonic elements function and interact, okay? So what I mean by that is, it's not going to be good enough to just find a picture of a building. You're going to have to find several that show it from different angles, that show how it kind of comes together. Ideally, show some examples of how things join, So maybe you'll also find some drawings, some of the original architectural drawings, and you can look at how things join. You'll get a sense then of how things come together and what I'm talking about. Okay? I also want you to do your own architectonic diagram. Put on your architectonic eyes and pick a location near you, a home, a school, etc., where you can see the tectonic elements of mass, plane and frame in a built structure. Okay, so take some pictures of this building or buildings even and print them out. Okay, so I would suggest actually the thing to do would be to print out in black and white, photocopies basically, and then get yourself a pen or a pencil. I would suggest even a red pen or pencil, because then it's going to really stand out, really help you to pick out those elements. And then you can quickly sketch the tectonic elements. You can use thick lines for the mass, you can use thin lines for the planes, dashed lines for frames, for example, and reveal the hidden tectonics of your chosen building. Okay, I hope that's clear. I hope you get what you need to do. If you don't, you can email me, you can WhatsApp me, you can contact me through Instagram. There's lots of ways to get in touch with me. I'm sure it's not too difficult. You can even leave a comment in the comments of this video below. You can subscribe, you can like, of course, if you liked. If you didn't, shut up, keep quiet. Too bad. And yeah. Okay, when you've done this, I'd like you to put it together into a beautifully illustrated A4 document in PDF format and email that to me. Keep yourself a hard copy for later review. Okay, that's it, people. That's it for today. That's Architectonics, and yeah, I hope you've learned something there. I hope you've kind of got some sense of what Architectonics is about. As I say, if it's confused, unclear, whatever, just hit me up and ask me some questions in whatever way you feel appropriate. We'll try and have a Skype catch-up on this at a later stage this week. But for now, I'm going to love you and leave you there, and I'm going to ask you to take care of one another, and I will see you again soon. Bye for now.